In this video, we're going to talk about combustion reactions. Combustion means to add oxygen. So normally a compound composed of carbon, hydrogen, and maybe oxygen is reacted with oxygen. This type of reaction is usually called burning. A combustion reaction is a burning reaction. So if you burn something, you are combusting it. So there's two types of combustion reactions, a complete combustion reaction and an incomplete combustion reaction. If the combustion is complete, the products will be carbon dioxide and water. If the combustion is incomplete, the products will just be carbon monoxide or possibly just carbon and water. So let's do some examples here. We're going to assume a complete combustion reaction of this hydrocarbon. So if it's complete combustion, I'm going to make carbon dioxide and water. It appears nothing's left over. This will burn so completely that there will be nothing but gases that will be invisible to the eye. Okay, but like all chemical reactions, we need to balance them correctly. So let's go ahead and try to do this one. I have 4 carbons on the left and 1 on the right. So we'll put a 4 in front of our carbon dioxide on the right. I have 10 oxygens on the left and 2 on the right. So I'll put a 5 in front of the hydrogen on the right. 10 hydrogens are both balanced on each side. And last we have oxygens. So on the right I have 5 plus 4 times 2, that's 8. 8 plus 5 is 13. On the left I have 2. So I have 2 and 13. I've run into the odd-even problem. Hopefully you remember how to solve this. If you run into a problem where I have an odd number on one side and an even number on the other, the only way to solve this is to double everything and try again. So there's no coefficient here, but it's really a 1. So we're going to double it to a 2. This 4, we will double it to an 8. And this 5, we will get rid of that and double it to a 10. Now if you doubled correctly, everything should still balance. 2 times 4 is 8 carbons, 8 carbons. 2 times 10 is 20 hydrogens, 10 times 2 is 20 hydrogens. Okay, we still have our oxygens to go though. 8 times 2 is 16, plus 10 is 26 oxygens on the right, and 2 on the left. So the coefficient we need to put here is a 13. Next, we have an incomplete combustion reaction. So our products this time are just going to be carbon monoxide and water. So in order to balance this one, I have 4 carbons on the left, 1 on the right, so I'll put a 4 there. I have 10 hydrogens on the left and 2 on the right, so I'll put a 5 there. And now we check our oxygens. I have 5 oxygens plus 4 oxygens, that's 9. And on the left I have 2. We've run into the odd-even problem once again. You'll find that with combustion reactions. There's a lot of odd-even issues here. But no problem, we know how to do this. We double everything and try again. So we double that 1 to a 2, double this 4 to an 8, and double this 5 to a 10. Okay, everything is still balanced except the oxygens. Let's check how many we need now. I have these 8 oxygens plus these 10. That's 18 oxygens on the right. That's an even number. And 2 oxygens on the left. So I just need a 9. 9 times 2 is 18. So a combustion reaction always includes the same types of reactants. You have a hydrocarbon, which is some unknown number of carbons. That's what the N stands for. I have N number of carbons. It doesn't matter. Plus N number of hydrogens. Again, it doesn't matter. Sometimes you can throw an oxygen in there and it's still a hydrocarbon. Well, it would not technically be a hydrocarbon, but it still could be a compound, an organic compound that's combustible. And there are other reactant, of course, is oxygen. We need some sort of carbon reacting with some sort of oxygen. They also have one of 2 sets of products. If it's a complete combustion reaction, you just get carbon dioxide and water. If it's an incomplete combustion reaction, you get some other combination of these. Now, on a test question, they would have to tell you, I would have to tell you whether it was a complete or an incomplete combustion. More often than not, you just need to recognize that this is a combustion reaction. If you see hydrocarbons and oxygens reacting to produce some form of either carbon dioxide or carbon monoxide and water, and possibly carbon. So let's also summarize everything we've learned about the types of chemical reactions so far, because this is the last one. An equation describes a reaction, and it must be balanced in order to follow the law of conservation of mass. You can only balance these by changing the coefficients. That's the big numbers in front. Equations have special symbols that indicate the physical state and if a catalyst or an energy is required. Reactions come in 5 major types: synthesis or combination, decomposition, single and double replacement reactions, and a combustion reaction. We can tell what type they are by looking at the reactants. This just comes down to practice and recognizing the patterns in the reactants that you see in the types of reactions that it is. Remember, single replacement reactions are based on the activity series, table J. You have to be higher on table J in order to do the replacing. And don't forget to assign charges and crisscross and balance.